All right. Yeah, so for this one, while we ended, I was saying you can solve it properly by shading, where you say you draw the Venn diagram like the way I drew here. You draw it here, and then from there you shade A, which we shaded to be this part here. Then after shading where A is, you also shade B complement. So B complement is simply just what is outside B. So when you shade the outside part of B, that is your B complement. And then after shading, you can now write your answer. Yeah. You can now write your answer. Okay. So here the answer will still just be that. All right, so let's quickly move on to the next one, which is simplify. Okay, so the next question is simply just simplify. Okay, simply just simplify this. Simplify the following. Yeah, simply just simplify the following. Let me just erase this. There's a question. All right. So someone is saying explain again on 3. All right, let me just repeat. So the same way I'm going to solve 3 is exactly how you solve even the previous questions in case you didn't understand them. These ones, this one and this one. The same way I'll explain it here, that's the best way you can solve it. So if you've been taught to simplify such questions, simply just have to draw the Venn diagram. That's the simplest way you can find them. So you put E there to represent the inverse set. And then the question is saying A is a subset of B. So A is a subset of B. So we shared A, we also shared B complement, and then we find the union set. Okay, so if you want, you can use Demogan'S here. You can say this is equal to, you say A complement intersection B, then you put everything under the complement. And then after finding that, you find the complement of your answer. But that I think you just take your time. The best is just to sketch. I mean to sketch, to draw the Venn diagram. So when you draw the Venn diagram, you shade your A. Let us shade A. So when you shade A is simply just this part here. And then you also shade B complement. B complement is simply what is outside there. So when you shade what is outside, the question is asking us to find the union. We said union is simply just the addition of two sets. So here when you add the set A, you also add a B complement. You discover that there will be, you not have anything that you are going to have that will be common between the two sets, in short. That we're going to write as one. Like for instance, let us try to shade this one. Maybe that's when you get the point properly. Let's try to shade part B. So write E there, and then we have A. We have B there, and then we also have A inside. And then let's try to shade this one. So shading this one, I mean, we shade A complement. So when we shade A complement, let me just use different colors. So we're going to shade A complement. So A complement is simply just everything that is outside A. That is A complement. And then let us also shade B complement. So B complement will simply just be everything that is outside B. Let me use another color, another different color. Okay, let me use black. So when you shade B complement, we're going to have something like this. Yeah, so now when you combine the two shades, the one that is outside for B complement and the one for A complement, because we're adding two sets. because we have been told to find the union between the two sets. So when you find the union between what I've shaded, which is just B complement, and you shade A complement, when you combine the two sets, you discover that your answer will just be the same as A complement, because you're going to add A complement plus B complement, which will just give you A complement as your answer. If we talk about this other one, which is A intersection B, so A intersection B, if we've been told to shade, this is our B, this is our A. So A intersection B, we can first shade A, we shade A there, then we also shade B. So we also shade B. And then since we're finding intersection, intersection is simply just the common elements between the two. So while the shadings are meeting, that's where our answer lies, which is just the same as writing A as your answer. So A intersection B, the answer is simply just A. And then for this one, we've been asked to find the union set between A and B complement. The union set between A and B complement is just the same as adding A and B complement, which is just the same as writing A union B complement, which is just the same. Yeah, there's no difference. Because there's no, if we had numbers there, it would have been easier for us to just list numbers. But here, we've just been told to simplify. So you just go direct and write the same thing, that's all. Okay, so let's quickly move on to the next one. Okay. So the next question is simply just asking us to simplify again. So this one, if you want, you can also be sketching, but the best way is for you to use the laws of sets. So we have X, we have X complement union, open brackets there. Sorry, they're using parentheses. So open brackets, then we have Y intersection Z, then close brackets, we have a complement outside. So first of all, we deal with what is in the big brackets. So we distribute this complement. So this complement and this complement will cancel. So we just have something like X, and then the sign there will change, become intersection. Then open brackets, have Y, we have Y intersection Z, and then the complement comes out there. We're distributing this complement throughout what is in the brackets. And then we also now distribute the complements in the in these brackets. So we're going to have X intersection, then Y complement union Z complement. So for this one, I think it can't be simplified further. Yeah, it can be simplified further. We can just leave it like this. Or if you want, you can distribute, you can use the distributive law. You say X intersection Y complement, X intersection Y complement in brackets, and then you say union, then X intersection Z complement. Yeah, you can't simplify it further than this. This is how you simplify it. Okay. So let us also do the second one. So let me just demarcate here. So the second one is simply just Y union X intersection Y. So this one you just use the distributive, you just distribute them. Have Y union X. I'm going to have Y union X in brackets, and then you write this symbol there. Then Y union Z. Sorry, Y union Y. So Y union Y. Yeah, so Y union Y, the answer is simply just Y. So I have Y union X, then intersection Y. You can't go further than this. Okay, so let's look at the other one, which is this one. Let me just erase this first. Okay, so the last one there is X intersection. X intersection Y, and then, and so the last one there is simply just X intersection Y in brackets. Then you have union X intersection Y complement. So what is common between this? So this is the associative law that we want to, this is already distributed, so we can take it in the format of the associative law. So we look at the common part, which is X intersection, X intersection. We write it there, X intersection, and then we open the brackets. So we have Y, we just remain with Y there. And then you have union there, then you have Y complement there. Okay, so we have X intersection. What is Y union Y complement? Y union Y complement is simply just the universal set. So I'm going to use E to represent the universal set. So Y union Y complement is just the universal set. How does it become the universal set? You have this set here, and then you have Y as your set there. This is E. So we have Y, and then we find the, we add the two sets. This Y here, and you also add it to Y complement. Y complement is simply just what is outside Y. So when you add Y plus what is outside Y, you just come up with what is called the universal set. And then X intersection, the universal set, the answer is just X. So you can revisit the rules of sets. I wrote them in the slide at the end. Yeah, so simplifying this set just gives you X as your answer. So let's quickly move on to the last question. Okay. And so the last question is simply just A complement intersection B complement. So A complement intersection B complement. So A complement intersection B complement. Oh, the question says if A and B are disjoint, meaning A intersection B is an empty set. So if they talk about two disjoint sets, let me just draw what they're talking about here. So if they say A intersection B, if they say A and B are disjoint sets, means that the two sets have no intersection, or rather the two sets, the intersection set between the two sets are simply just, it's simply just an empty set. So you have this set there, then you have A, they are saying that disjoint, meaning they are not joined at any point, meaning A and B do not have an intersection. So if they ask you to find A complement intersection B complement, here we can use Demogan'S, which will just be the same as A union B, union B complement. So what is A union B? A union B simply, they're saying A complement intersection B complement. Okay, let me just mute everyone. All right, so A complement intersection B complement. So A union B will simply just be A union B. That's all. Because you don't have anything common or anything that you can miss for this set. So simplifying this set will just end here, because they are asking us to simplify this given that A and B are disjoint sets. So you can just end here. And then the next one is A intersection B, and then complement outside there. So A intersection B and then complement outside. So this we can also use Demogan'S, which will just be A union. When you distribute this, this is just going to be A. Okay, actually, we don't have to do the distribution here of the complement. Let's just go straight by finding the answer. So the answer here will simply just be, we know that A intersection B has been given in the question there to say it's an empty set. So we put an empty set there, and then an empty set complement will simply just give you the universal set when you check the rules of sets. So an empty set complement will give you the universal set. So that's the answer there. I don't know if you have any questions before we can proceed. Okay, since there are no questions, so let us also simplify this. The question is saying, this is question 4, which says using associative and distributive properties of union and intersection sets, derive the following. So they're asking us to say, prove that this part is equal to X. So let us get A. A is simply just A X intersection Y in brackets, and then union X intersection Y complement. So there, what we can just do is simply this is already distributed, so we can take it to the normal form by using the associative. So we look at what is common. So X intersection is common, X intersection is common there. So we write X intersection there. Then whatever remains, we put them in the brackets. So we have Y there, then we have union there. We also have Y complement there. So Y complement, we write it there. So from there, Y union, Y complement, we simply just, so we write X intersection there. Y union, Y complement, remember I said it's a universal set. Yeah, so X intersection universal set will just give us X, meaning we have proved that this part is equal to X. Let us also prove the second part there. So for the second part, they want us to prove that this whole part here is just equal to X union Y. So we can, even just from here, we can just start by picking the common thing. So the common thing is X intersection. Even there we have X intersection. So when we put X intersection outside, whatever remains between the first two sets, this one and this one there, we put them in the brackets. So we have X intersection, and then we remain with Y union Y complement. So we're going to remain with Y union Y complement like that. And then outside this side, we have union X complement intersection Y. We have union X complement intersection Y in brackets. So we have X intersection. So this part, we found that it's it's a universal set, and then we say this is union, and then we have X intersection, X complement intersection Y. So from there, X intersection universal set is simply just X. Then we remain with U. Then this other part, which is X complement intersection Y. So we distribute this using the distributive law, where we say X union X complement in brackets, and then the symbol there is intersection. Then we say X union Y. So X union Y. So X union X complement, the answer gives us the universal set. We say this is intersection X union Y. So from there, we say any set, remember this part where we said set X intersection the universal set, the answer is just set X. So any set intersection the universal set, the answer is just that set. So here, this set X union Y intersection the universal set there, the answer is just this same set, which is X union Y. Yeah, so this is how you simplify. And we've managed to simplify that this part is equal to X union Y. So let's quickly move on to the other question. Okay. So the other question is simply just, they want us to prove that X union Y complement intersection Y is simply just the same as X union Y. They want us to prove that this is equal to that. So let us take this left-hand side. So we actually, we're not even supposed to distribute. What is X complement? What is Y complement intersection Y? So we're simply finding the common elements between what is outside Y and what is inside Y. So the common elements between Y complement and Y is simply just an empty set, because there's no way you can find the common elements between what is in the room, for instance, and what is not in the room. I don't know if you've gotten that concept. Okay, let me just say you have Y there, you have, this is set Y, then you have the universal set there. So they are trying to ask us to find a common element between what is in Y, which is just this Y, And then y complement is simply just what is outside y this side. What is outside y? So what is the common elements between what is in y and y, what is outside y? So the answer is simply just an empty set union x. And then when you find the union set between an empty set, yeah, an empty set and yeah, I think there was an error somewhere. It wasn't supposed to be like this. This was supposed to just have x outside. I mean, this wasn't supposed to be there because y intersection y complement is simply just an empty set, and then an empty set union x, the answer is just x. So meaning this part wasn't supposed to be x union y, but it was just supposed to be x. Yeah, so this was supposed to be the answer, not x union y. Okay. Let's quickly move on. So the other question is just x intersection x union y. We prove that this is equal to x. Okay, so we have x intersection x union y. So we prove that this is just equal to x. So we distribute this. We have x intersection x, x intersection x, and then union x intersection y. Okay, let's see. This is not an error as well. Okay, so x intersection x, the answer x intersection x, the answer is simply just x. And then you say union x intersection y, x intersection y. This will just give us x. I mean, this will just remain like this. So even that one was just an error. It wasn't supposed to give you x. This would have given us x if at all they said this was maybe, which one? Maybe one of these, if one of these had a complement, maybe it would have made sense. Or if they had said in the question, to say where x and y are disjoint sets. So if they said x and y are disjoint sets, the answer here would have given us, okay, sorry for that. So if they said x and y are disjoint sets, the answer would have given us x here. Yeah, so that is how you simply do everything. Yeah, so on these two questions here, these two questions, there was an error. Yeah, so you can try to solve them through and prove as well that there's an error. Okay, so let's move on. So we have the last question here, which says using the set notation to describe each of the following shaded sets in the diagram. So they're saying use set notation to describe each of the following shaded shaded sets in the diagram below. So the first one there, just by looking at it, you can say that this one is A complement, and then A complement is simply just what is outside A. That is A complement. So A complement is what is outside A, and then when we intersect A complement with B, so B is simply just this part. We get that shaded region. So the first one there, which is our part A there, is simply just A complement intersection B. And then the second part, which is part B, this one here. So when you look at this is just the same as maybe saying we combine A union B, because when you combine A union B is simply just this part. When you shade this part, that is A union B. And then we intersect A union B with C. So we intersect A union B with C. That's when you can have this region shaded. So that is just the same as A union B in brackets, and then intersection C. A union B and then intersection C. Then the other part, which is part C, this one. So this one is just the same as B intersection C. When we say B intersection C, we're talking about, so B intersection C, let me shade B intersection C. So B intersection C is simply just this part here. This part, and then we also maybe include A complement. So A complement will just involve, so A complement will just be everything that is outside A. So when you shade everything that is outside A, yeah, so the part where the two colors are meeting, that's that's our shaded region. So we have this part here, that's where we have black and red. So that region can just be written as A complement intersection B intersection C. So B intersection C, then intersection A complement. Yeah, intersection A complement. That would be that region. Let's move on to this other region. So this other region is this shaded part. So this shaded part is just the same as B intersection C, or not really intersection, but B union C complement. When we shade B union C complement, we are simply talking about this part outside B union C. The part outside B union C, that is B union C complement, and then intersection A. So our A is simply just this part. Our A is simply just that part. So if we're to write that in set notation, we can just say B union C, then complement, and then intersection A. B union C complement intersection A. Yeah, so B union C complement intersection A, that is the region that has been shaded there. So let us move on to this other region. I mean, this other set E. So this one, the shaded part, we have A intersection B intersection C complement is shaded, but there's also we have A intersection, not really intersection, but A union B union C complement is shaded. So when we shade A union B union C, when we shade this, but complement, the complement of this is simply just what is outside A union B union C. So when we shade that, but how do we combine this outside part with what is in between there? Because what is in between there is simply just, so we combine two sets by using union. So we say union A, that one is just A intersection B intersection C. Yeah, so this is simply, this is how you can simplify it. If you want, you can simplify this further. Okay, so let's look at the last part. So the last part is simple. That is F. So F is straightforward, is just A union B union C complement. So the complement of that is simply just what is outside the union of those three sets. All right, so we have a question. The question. E, someone is saying we repeat E. So E is straightforward. Let me even erase everything. Okay, so E, someone is saying repeat E. Okay, so E, we know that if we shade this outside part here, the outside part of the three sets is simply just, so this is E. The outside part of the three sets is simply just A union B union C, and then complement. When we talk about the union is what is inside the three sets, but if we say complement, it means that what is outside the three sets, which is just A union B union C, complement. So it's that part. So from there we can now, so from there we can now find means of how we can join this set here. So this other shaded part, the middle part, the middle shaded
Anything else?
The middle shaded part there is simply just A intersection. Sorry, I've written an equal sign there. So the middle part, this one here, we know that joining two sets or addition of two sets is simply just union. So we unite this set with what is in between. So the in between part there is simply just A intersection B intersection C. So when you find A intersection B intersection C, this is just the middle part there. That is the common part between the three sets. And then, yeah, this is how you can just write it. If you want, you can distribute the complement, and then after distributing the complement, you combine the sets with these other sets. If you want to simplify it further, but even this one is a simplified version of this question. Okay. So that is how you do it. Yeah. So if you don't have questions, we call it a day. I'm going to send the recorded sessions to the group. Yeah, as soon as I finish the meeting.
Excuse me, sir.
All right. Yes, you can ask.
Yes, on the same E.
Okay.
I've seen that shaded part is not even represented on the answer. So I'm confused why this
It's
part
here.
here
The
on
shaded
the
part is here. The shaded, yeah.
Oh,
Yes.
okay. Thank you.
All right, you're most welcome. Okay, so if you don't have questions, we call it a day. Let's meet on Monday for a new topic, which is the number systems. It's also a very simple topic like sets. Okay, see you in the next lesson on Monday.
Okay, bye. Thank you.
All right.
Thank you.
Thank
All
you.
right.
Thank you.
Rumba.